you. Good morning, guys. Welcome to this session this morning. Our topic this morning is the DStv SATIP IP solution. Thank you for taking the time out to join us this morning on this. We'd like to share this interesting topic with you and trust that you will find it informative. A little bit of housekeeping. All attendees' microphones are muted. All attendees' cameras are turned off, and that's just to keep it orderly. We will have a Q&A session following the presentation. So please, if you have any questions, please hold on to them. And then once the presentation has been completed, we will allow for a Q&A session. If you look at the bottom of your screen, if it's not visible, just move your mouse down. You will see the option for raise hand and Q&A. The Q&A session will be, you can access the Q&A session once we have completed the presentation. So our agenda for today is we will look at what is DStv SATIP, the building blocks of the solution, SATIP network design, SATIP system configuration, and then at the end of the day, we will have the Q&A session as mentioned before. Okay, so what is DStv SATIP? DStv SATIP allows for the distribution of digital satellite television signals via an IP-based, basically a computer-based network infrastructure. The DVB-S and S2 signals are received from a transmitting satellite using a Ku-band reception antenna, so satellite dish. So that's a fairly normal situation where you have a satellite dish pointing at a satellite receiving the signals. The signals are then down converted in the LMB and distributed via coaxial or fiber optic cable to the head end, which is still fairly standard. And then at the head end, which in this case is a digital DStv SATIP server, the RF radio frequency signals are demodulated and an IP transport layer is added. So this is where the differences come in. The addition of the IP transport layer allows for the distribution of digital satellite television signals via an IP, which is Internet Protocol-based LAN, which is a local area network infrastructure. DStv SATIP distributes live satellite television programs over an IP network transparently and without decrypting the encrypted signals. So the signals are received from a satellite, an IP layer is added to it, and it is transported without touching or manipulating the signal in any way whatsoever. At the viewing point, a multi-choice DStv set-top box is required to convert the IP stream to an HDMI or AV feed and to decrypt the encrypted signals. So at our viewing points, we have a DStv decoder. It receives the IP signal, decrypts it, and gives us an HDMI or AV output, which can then be connected directly into the TV set. Typical applications, where do we use DStv SATIP? DStv SATIP has been designed for use in DStv commercial installations only. That's quite important, that it's only used in commercial installations. Typical applications being guest houses, small to medium hotels, lodges, boutique hotels, hospitals, offices, pubs, clubs, sports bars, and shopping malls. And I'm sure there are others, but it's all commercial installations, and it may not be used in a domestic environment. So it's not designed for your affluent customers that want 10 decoders in their homes. It is only used for commercial applications. So why would we use DStv SATIP? It gives us a very cost-effective IP distribution network because it eliminates the need for costly third-party IP solutions. No network configuration required on single service networks. So if you have a single service network, in other words, your network will only be carrying the SATIP service. Layer 2 unmanaged network switches may be used, and therefore there is virtually no network configuration required. The scalable solution, the system can be scaled for larger deployments. So depending on how many endpoints you are trying to supply signal to, the system is fully scalable. And as we go through the presentation today, you will get a clear understanding of how this is possible. No need for costly third-party DRM encryption. So to comply with regulation from MultiChoice and also the content owners, all digital distribution has to be encrypted to the end. So in most cases, when we do HD distribution, may it be on coaxial or IP platforms, we need to re-encrypt the signals before distributing it through the network. These third-party encryption systems are often very costly and pushes up the cost of such a deployment very high, making it virtually impossible for smaller applications due to the high cost. With SATIP, we overcome this problem, and we are able to give the guys the service at a very reasonable cost. And the important thing, last point here today on this slide, is HD viewing at all endpoints. So obviously we are using HD decoders at every viewing point, and it has a direct HDMI connection to the TV set, which now allows each viewing point to have HD quality images, which is pretty much what most of these hospitality venues and other venues are looking for today. So there are 4 main components in a DStv distribution system, the building blocks of such a network. And the first one is the reception part. We use a commercial grade satellite dish with either a wideband SATCR or optic LMB. The processing, which is the head end, consisting of the DStv SATIP server or multiples of servers, depending on the size of your network. And then we have the distribution network, which is an IP-based network with switches linked with Cat5e or 6 cable or fiber optic cable in large networks can be used. And then the fourth building block is the viewing environment, where we have the MultiChoice decoders connected to the TVs at each viewing point. So those are the 4 main building blocks, and we will look at each of them individually now and analyze them. So the first building block being the reception side of the system. So reception is done by a standard KU band satellite dish. Always use a commercial grade satellite dish. It's important that you are doing a commercial installation, and therefore a commercial grade satellite dish is required. The general rule is in any commercial installation, always use a larger dish than what is used for domestic installations in your area. So as we use an 80 centimeter dish as a domestic dish in South Africa, a 1 or even preferably a 1.2 meter dish is recommended for any commercial installation, which obviously includes the SATIP solution. As I said, the 1.2 meter dish is recommended. It just gives you a better quality of signal at the starting point. It also minimizes issues like rain fade, etc., ensuring that the viewers on this commercial system has the best possible service. Obviously ensure that a suitable LMB is installed to feed the DVB-S or S2 signals from the satellite to the SATIP servers. This is quite important, and we'll go through the different types of LMBs in this presentation today. And something very, very important is the dish alignment and the LMB skew angle. It's very important because we are converting signals, we are manipulating signals within the DStv SATIP server, which makes these type of parameters much more critical than it would be in a standard domestic installation. So choosing the correct LMB, this is very important. Choosing the correct LMB to suit your installation is important, as this will have an impact on the rest of your installation. The first LMB which can be used as SATIP is the wideband LMB, which is probably new to many. So the wideband LNB is the preferred LNB for use with the DStv SATIP installation. The wideband LNB allows for the best performance and quickest response in this DStv SATIP network. Multiple DStv SATIP servers can be supplied with signal from a single wideband LNB because it's possible to do a little distribution system from the wideband LNB, allowing you to feed more than one server in larger networks. And then the other option is your standard smart LNB, which are used mainly in domestic installations. The smart LNB may be used in a DStv SATIP deployment. Due to the additional switching taking place in the smart LNB, remember the device, like with the decoder in domestic, it uses user bands, it requests information. This will affect the network performance, and it will be slightly slower when compared to the wideband LNB, where there's no switching taking place. And that is one of the reasons why the wideband LNB is also the preferred LNB for these installations. And a very, very important fact is one smart LNB equals one SATIP server. In other words, you cannot feed more than one server from a smart LNB, and this is due to the user band limitations. Your smart LNBs have 30 user bands shared across the outputs, depending on which model you use, and each SATIP server will require 24 user bands. So you will notice that you have 6 user bands unused, which is not sufficient to power or to supply signal to a second DStv SATIP server. So it's important that when you're using a smart LNB, you can only run one server per LNB. So it can be used in a smaller deployment where one server is all that's required, or which is not practical, but if you have more than one server, you will have to have a dish per server. And in certain distribution systems, fiber optic LNBs, etc., may be used. And we will discuss that in this presentation today. Okay, so for those of you who are not familiar with the wideband LNB, as we said, it's the preferred LNB for use in DStv SATIP installations. And it's also a growing technology, and I think we will see more and more of wideband technology being used as we go forward, not just in SATIP. So the wideband LNB has 2 outputs, and it's not to be confused with a twin LNB because it physically looks like a twin LNB. It's a standard looking LNB with 2 outputs. Output 1 of the wideband LNB provides vertical low and high signals simultaneously, and output 2 of the LNB provides horizontal low and high signals simultaneously. So instead of our normal quattro LNB, which we all became accustomed to, which gave us 4 outputs to give us the 4 polarities, low and high, vertical and horizontal, on a wideband LNB, you have all 4 polarities present on 2 cables. So which means all vertical and horizontal transponders are available simultaneously. Once again, similar to a quattro LNB, but in this case, we use the wideband outputs and we only have 2 outputs. There's obviously no switching in this LNB because the 2 outputs are fixed and have all those feeds available at any time. So looking at a spectrum, just to give you some idea of what they've done with the wideband LNB, if you look at the top, you have starting from your FM band, we have VHF running into UHF, and then we have a typical satellite IF band or L band, which is 950 to 2150 megahertz. And that is what we've been using up to now for satellite frequencies, and hence the reason why we have 4 polarities to get the high and low frequencies available simultaneously. So to achieve having high and low frequencies from one output, they had to widen the band, hence the wideband LNB. But they couldn't go too much higher up in the band because, as we all know, your losses in networks on coaxial cable, the higher the frequency, the higher the loss. Typical loss on a piece of RG6 today at the 2.15 megahertz. Top of the IF band sits in the region of about 30 dB per 100 meters. So you can imagine if we go much higher into the band, how extremely high losses in coaxial cable would become. So what they did with wideband is they actually went lower. And as you can see on your screen, that the wideband frequency runs between 290 megahertz and 2340 megahertz. So they went slightly higher, but they actually moved right down into the RF band to achieve this, to get the required 2050 megahertz bandwidth, which is the typical bandwidth of a full polarity low and high on the satellite that we are using. So this opens up some challenges in the sense that you are in the RF band, you got chances of interference from RF transmitters, etc. It also creates issues if you want to still add terrestrial TV into the system. It has to be done on a separate cable. So when using, and also you have a very wide spectrum to deal with, which coaxial slope, etc., has to be taken into account. So when using wideband, it is always important to use a very high quality cable and preferably something like a tri-shielded cable, which will minimize possible external interference into your system. But at the end of the day, wideband allows us for two polarities, having vertical low and high on the one and horizontal low and high on the other output. So two cables required for all four polarities instead of the four cables that we became accustomed to using the Quattro LMBs. There's just a basic spec of the wideband LMB. Your input frequencies is your standard KU band transmission frequencies between 10,700 and 12,750 megahertz. You will see that your output frequency range, instead of the 950 to 2150, now has grown to 290 megahertz to 2,340 megahertz, which is quite a wide spectrum. Obviously, your standard input impedance is still 75 ohm. Your supply voltage is similar to a Quattro LMB. Anything between 9 and 19 volts, the LMB will operate. There's no switching voltage, just like in a normal legacy type LMB. The current consumption depends on the manufacturer. This is spec'd on the MultiChoice branded wideband LMB, is 120 milliamps. And then the other important thing is that the oscillator, which we are used to being 9750 and 10600, the two oscillators in a standard universal LMB, the wideband LMB has a single oscillator at 10,410 megahertz. And when purchasing wideband LMBs, just be careful. There are some LMBs that have been made with a 10,400 megahertz oscillator, which will mean everything in your system will be 10 megahertz off and will not function correctly. Obviously, the MultiChoice branded wideband LMB and other wideband LMBs supplied by Space TV will definitely have the 10410 megahertz. Just watch out if you buy in the market that you always make sure that you have a 10410 megahertz oscillator in your LMB. The connectors are just two standard F connectors. Like we said, looks like a twin LMB, and your mounting is the standard 40 mil, which will fit into the standard dish mounting. Here's just a quick picture of a wideband spectrum, which is the vertical and horizontal low simultaneously. So how do we set up a dish? We now have this very wide spectrum ranging between 290 megahertz and 2,340 megahertz. And most of the meters that we've grown accustomed to, and the guys probably have, only allows a 950 to 2150 spectrum or bandwidth in the satellite frequency range. So the Rover HD Tab 700 Plus and the Tab 900 Plus instruments available from Space Television are equipped with wideband. They are wideband compatible and therefore have the wideband tuners in them, which will allow you to access the full wideband spectrum, as I showed you earlier, and help you align dishes and do installations, etc. The problem is not very many people have these instruments, and they unfortunately are quite pricey. So how do we set up a dish with a wideband LMB if your field strength meter does not have a wideband tuner. We are now going to run an on-screen poll with this question, and you will see it pop up on your screen, and then you can all vote yes or no. So the question is, when installing a dish with a wideband LMB using a meter without a wideband tuner, you align the dish using a single LMB, and once the dish is aligned, you swap the single LMB with a wideband LMB. You can either click yes or no, and then just click submit. We will give a few minutes for this. Once you click submit, it should disappear from your screen, and Mark, who's driving it on the other side, will share the poll with us as soon as most of you guys have voted. Is that the solution? Do we use a single LMB to align the dish and then swap the LMB? Is that the solution, yes or no, if your meter does not have a wideband tuner? Mark, how's the poll looking on your side?
We've got about 67% of people who voted so far, so we're just going to give it half a minute more.
Okay, no problem.
All right, I'm going to end the poll and then share the results with you.
Okay, fantastic. Thanks, Mark. Okay, so the results of the poll, so 72% of the people who voted agree that you would align the dish with a single LMB and then swap the LMB once the dish has been aligned and install your wideband LMB. 28% of the voters did not agree. Okay, so thank you, Mark, for that. I have to unfortunately disappoint you and say that the 70-odd% that agreed are all wrong. Because yes, you will align the dish, sure, so the dish will be in alignment. But as soon as you swap the LMB, how do you actually set the skew angle on that LMB now? And as I said earlier in the start of this presentation, the skew angle becomes very critical in these type of installations. So no, you do not swap the LMB. You actually use the wideband LMB to align your dish and set the skew angle. But we've just said that the frequency range is a lot wider than what your meter can see. So how do we do this? If you look at a legacy LMB versus a wideband LMB, you'll see the downlink frequency obviously stays the same, because that's a standard KU band downlink frequency, 10.7 to 12.75 gigahertz. The tuner frequency for legacy is 950 to 2150 versus wideband, which is 290 versus 2340. So the total bandwidth required on a legacy system is 1200 megahertz, while the wideband is 2050 megahertz. So you'll see that there's like 850 megahertz of bandwidth more in wideband. The obviously local oscillators, as we mentioned before, your legacy LMB have two oscillators, the low band 950 and 9750 and 10600. I see there's a typo there, and your wideband being 10410 megahertz. Okay, so here's the trick. If you look at this slide, you will see that your satellite IF band being 950 to 2150, which is used in low band and in high band, and there's your wideband, which runs between 290 and 2340. But if you look between your red lines, that is what a standard meter can see. So there's a large portion of the wideband spectrum which could still be visible on your instrument. If you have something like a Rover Tab 7 or etc., which has an extended spectrum, which runs between 930 and 2600 megahertz, that are the two purple lines, you will see that you can basically see a little bit lower down, and you can see right to the top end of the wideband spectrum. So even with a standard meter, the section between the red lines is still visible on your meter. And the only way, or this easy way to achieve it, is all you do, you go into your meter, into the settings, and you change the oscillator frequency. So your oscillator frequency will be set to 9750, sorry about the typo there. You just change the oscillator frequency in your meter to 10410. And that will allow you to see a section of the spectrum while you're still using a wideband LMB, and that will allow you to align the dish and set up the skew, etc., to make sure your dish is perfectly aligned and installed while using a standard meter. If you look at the spectrum below, this was done with a Tab 7. On the left-hand side, you'll see there's a standard vertical low spectrum using the 9750 oscillator. And on the right-hand side, you will see there's a vertical feed from a wideband LMB using the 10410 oscillator. And you will notice that the transponders which are in the red block on the left-hand part of the image, those are not visible on the right-hand side image. So that's part of what you will lose, and that is that section over here, which you are not receiving. But within there, you'll see there's 11594, which is your home frequency. That's still visible. So there's more than enough information for you to align the dish with the limited spectrum that you are able to see on a standard instrument. If you go to the Space TV website, you will see on the top link, there's a link to videos. Under the videos, you'll see various categories, and there's a category called test instrument and signal analyzers. If you go there, you will find various videos on instruments, and amongst them, you will find for different models ranging from the SatLinks to the Ultra, and obviously the older Rover instruments, explaining to you how to change the oscillator in your meter and do the dish alignment as I've just mentioned to you. So on the Space TV website, under videos, test instruments, you will find the necessary information to set up your meters to align dishes with wideband LMBs if you do not have a meter with a wideband tuner in it. Our next building block that we will be looking at is the processing, the SATIP processing. So in this case, it will be a DStv SATIP server. The DStv SATIP distribution system, it then consists of one or more DStv SATIP servers, depending on your network size. The DStv SATIP server receives the DVB-S S2 signals from a wideband or unicable feed, as we've mentioned. The DStv SATIP server demodulates the DVB-S S2 signals and adds the IP transport layer. And each DStv SATIP server can provide up to 23 concurrent video IP streams and 1 data stream, 24 consecutive streams. So what this means is that each server can feed 23 decoders maximum. So if your system is small and you have 23 or less, you can use 1 server. If you have, hypothetically speaking, 40 points, you will use 2 servers, etc. And that is how you can scale your system to accommodate however many points you need to feed in your distribution system. So the SATIP server, basic specs, we said the input is either unicable or wideband. It does not receive a legacy input. The input frequency is obviously wideband 290 to 2340 on our wideband spectrum. The output IP stream format of the DStv SATIP server is RTP real-time transport protocol, and it's in unicast, which is important. Just remember unicast, we're going to talk about that now. Obviously, the supply voltage is 12 volts, it comes with its own external power supply, consumes about 4 amps of power. The output voltage is 19 volts, so that's to power your smart LMB or your wideband LMB. Once again, there's obviously no switching. It can supply about 1 amp of power. And the inputs and output connectors, the RF connectors on this device are standard F connectors, as you can see on the picture on the right-hand side. So there's a bigger picture close-up of the back end of the SATIP server, and starting on the left, you will see the F connector with a white surround. It's marked unicable input. So if you are feeding the server from a unicable feed or the smart LMB, you will connect your input to the first far left F connector. Should you be using a wideband LMB, obviously you will have 2 cables coming in, and you will see that the purple block covers both. So the input on the left also says wideband vertical, and the input on the right says wideband horizontal. So that is where you would connect your wideband LMB. Very important not to mix the horizontal and vertical up. Like with a Quattro LMB, if you swap the two around, your system will not function. The next connector there is a USB port, which is not used for the normal setup of the system. It could be used for upgrades, etc., but it doesn't affect the functionality of the actual wide SATIP service system. Your next connector is an Ethernet connector. It's RJ45 connector. So this is going to become your output. Remember, we are now using a LAN type network. So that RJ45 Ethernet port becomes your output. So you have satellite in and you have Ethernet out on the DStv SATIP server. Your next connector there is just a little reset button, which I will talk about a bit more later. And then on the far right, there is your DC input from the power supply, which is supplied with the unit. And there's a power on off switch. We've had people that have been caught out with that switch. So just make sure that you do turn the switch to on before you try and get your system to work. So the little server has various built-in functions, and one of them is an automatic input selection. So the DStv SATIP server input has been designed to receive signals from a single SAT-CR or unicable feed, as we said, or from the twin wideband feed. So you can either have both, as we've discussed. And this little server is able to determine automatically which type of LMB you've actually connected to it. So how does this work? On boot up, the DStv SATIP server will query the attached input device using dissect commands, typical SAT-CR unicable type setup. If the DStv SATIP server receives a response from the attached input device, it will switch the input to unicable mode using the DStv allocated user bands. Because obviously, as with the decoder, as soon as the server sends a command up to a smart LMB, it will respond and send a command back down to the server, which will then indicate to the server that it is actually connected to a SATIP, to a unicable LMB. If no response is received, obviously the wideband LMB does not have that functionality. The server will automatically default to a wideband input. So basically the server will determine automatically which of the 2 LMB types or feed types you have connected to it. And it's important to know that the DStv SATIP server is only compatible with the EN 50607 unicable 2 devices. Now, it's not a big challenge. Most of the devices available in the market today are all EN 50607 standard devices. The very first generation of Explorer switches, the little black ones that came with Explorers in the box, that was a unicable 1 EN 50494 standard device. You might remember that that device only had 5 user bands, which is obviously not sufficient for the server. And that is hence the reason why it is not compatible with unicable 1, because they were limited to a maximum of 8 user bands. and we require at least 24 user bands if we use a unicable feed on the SATIP server. And this is another very important thing when it comes to the automatic input selection. Once the DStv SATIP server has been configured to a unicable input or to a wideband input, it will remain in the unicable or wideband mode even if the LMB input is swapped to wideband. So in other words, if you boot the server up the first time with a specific LMB type, may it be unicable or wideband, the server will stay locked into that mode. You can switch it off, you can pull the plug out. As soon as you plug it back in, it will default to the last LMB it was connected to. So what could happen, and we've had this issue before, where guys might set it up with a smart LMB initially, and then later on change over to a wideband LMB, and then find out that the device does not work because it's now not detecting the LMB. It's a very simple resolution. That little factory reset button I spoke about earlier, push that. I think you need to hold it in for about 10 seconds, which will factory reset the server and force it to go back through the boot up process and then detect the new LMB. But if you just swap the LMB, or even if you boot it with no LMB, it will default to wideband because it hasn't received the dissect command. And if you now try and plug in a smart LMB, it's not going to function. As I said, just push the reset button, hold it in for about 10 seconds, and the server will reboot itself and go through that whole boot up process again and detect the LMB. It's a very simple resolution, but it has caught out some people. This DStv SATIP server can also do automatic user band selection when you obviously feeding it with a unicable or SATCR LMB, which means it's not like the decoders where you had to go in and manually set up, in extra view scenarios, manually set up the user bands. The decoder will, the SATIP server will automatically detect it. So the DStv SATIP server can detect unused user bands on boot up and will automatically allocate unused bands for use with the server. How it works. So once the DStv SATIP server has determined that it's connected to a unicable input device, being the smart LMB typically, it will request that the unicable device clear all user bands. In other words, it requests the device to almost reset itself. The DStv SATIP server will then query the unicable device for available user bands. In other words, it will then build almost a log of what user bands are available on the LMB or whatever device it's fed from. The DStv SATIP server will now automatically allocate users bands starting from the back. So it starts from the highest numbers. So if you have a smart LMB which has 30 user bands, typically 0 to 29, it will start allocating from 29 backwards and not from 0 downwards, as one would have expected. And this is an interesting thing which is not necessarily commonly used, but you just keep this in mind, that the DStv SATIP server may coexist with satellite decoders on the same unicable device if the maximum number of user bands available on the unicable device is not exceeded. In other words, our unicable typical smart LMBs have 30 user bands, and the server only requires 24 maximum, which means there could be 6, or there will be 6 unused user bands on the device. Now, we said earlier that obviously this device is only for use in commercial installations. But what could happen is at a guest house, hypothetically speaking, often the owners live on the premises or they live in part of the actual house, and they might have their own domestic subscription on an Explorer decoder, etc. What can happen then is that that Explorer can still be coexist on that same LMB, just using one of the other outputs. And typically the Explorer will use 0, 1, and 2. And with automatic selection from the SATIP server, it will avoid those user bands. Like I said, so it's not something that will commonly be used, but it is possible. And if you come across it, it can be done. So just keep that in mind. The system can also be set up with an automatic server failover. In other words, you can add a redundancy server into your network. So should your server fail, especially when you have a large network with multiple servers, should the server fail, the redundant server would automatically take over the service and ensure continuity to your guests or your viewers. So the DStv SATIP servers are able to operate in redundancy mode in case of a server failure. How does that work? Each decoder connected to the DStv SATIP network will automatically construct an internal list of all available DStv SATIP servers on the network. So when the decoder boots, it will scan the network, and if there's more than one server present, it will build an internal table with a record of all the available servers. It will then obviously log onto a specific server of choice. Should the decoder detect a loss in signal from a chosen DStv SATIP server, it will automatically retune to the next available DStv SATIP server on its internal list, which means the server could have failed, but at least your guests will still have viewing and the channels will be alive. And this is always a good practice. These servers are not expensive. When you're building a larger network specifically, it's always a good practice to consider having a redundancy server in the network. So that is typically what your streaming from the server would look like. You would have, obviously you have a Cat5e or Cat6 cable running from your server to a network switch. And in that cable, you will have up to 23 concurrent streams, depending on how many decoders are connected. And as you will see, is each decoder gets its own dedicated stream. So the red stream is for decoder 1, green for 2, etc. And you will see that in this illustration, some are watching different channels, some are watching the same channel, but still they are each getting their own unique stream from the server. And then we also said that there's a 24th data stream involved. Now the data stream is shared across all 23 decoders. That's why we said that this server will use up to 24 user bands. So it's one user band for each decoder's viewing and a shared user band for the data stream, which carries your EPG and CA status, etc. All the data information is carried on a separate stream. But because that is standard information, it is shared across all decoders. So that is typically what it would look like. Is you would have video, 23 concurrent video streams and one data stream, and you will see that the data stream is shared with each unique video stream to each viewing point. That is typically what happens within the network. So that sort of covers the server. Our next an important part of this presentation today is the distribution network, because now we are working with a data type network, no longer coaxial tap splitters, multi-switches, etc., that we've all grown accustomed to. We are now using a completely different platform. So the DStv SATIP server network topology, the DStv SATIP uses an Ethernet LAN, which is a local area network topology for the distribution of linear television services. Unlike traditional coaxial cable, twisted pair cable is now used in a LAN distribution. All LAN network devices have unique IDs to ensure effective communication within the network, and that's called a MAC address, which is each device comes with out of the factory. Just as you and I talk to each other and we each have a name, so when I address a specific person, like I said earlier, I spoke to Mark, and Mark immediately knew I was addressing him. I was using his MAC address per se. The DStv SATIP, as we said earlier, uses a unicast, which is a one-to-one protocol for communication from the DStv SATIP server to the decoder in the network. That is what I showed you in the illustration as well. Each decoder gets its own unique little stream, as I showed you with the colors there. There's no sharing of streams, and that is called unicast protocol, and we'll discuss the differences now. And Another important factor to keep in mind is that each decoder on the network that requires around 30 megabits per second of bandwidth, that is data bandwidth. Once again, we've all grown accustomed to using megahertz as bandwidth, frequency related. We are now talking bits and bytes. So now our bandwidth requirements are measured in bits or bytes. And in this case, each decoder will require around 30 megabits per second of bandwidth on the network. And as we progress, you'll understand why that is so important. And as we said, one SATIP server can feed up to 23 decoders. And if you take the 30 megabits times 23, one server fully populated will require around 690 megabits. So that's 23 times 30, 690 megabits per second of total bandwidth per server within your network. Once again, these are important things to keep in mind when we plan these networks to ensure that we don't overload things which will cause additional issues. But as I said, we'll discuss it as we go along. Okay, so we spoke about unicast, and we said DStv SATIP uses a unicast protocol when streaming live television services to set-top boxes via an IP LAN network. So this very simple illustration shows you differences, because many of the third-party IP systems and also the Appear, which was used by MultiChoice previously, uses a multicast protocol. So on unicast, once again, it's a one-to-one stream. Each endpoint gets its own unique stream, where in a multicast protocol, it is a one-to-many. So more than one device can share a stream. So that's quite important to understand the difference between unicast and multicast. Multicast is one-to-many, and unicast is one-to-one. So here's a quick illustration of practical differences between unicast and multicast. If you look at this setup on the right-hand side of your screen, you will see that it represents a 60-channel multicast IPTV headend. Now, in a multicast IPTV headend, the signals are manipulated, information is stripped down, etc., etc. So typically for an HD stream, you would require about 15 megabits per second. And in this case, we said I have about 60 channels on that headend, which will, in this case, all be pushed out of that headend simultaneously, hence the very big green pipe in my illustration. And if you go 60 times 15 megabits per second, you have a 900 megabit per second stream running from the headend into the first network switch. If you look at the bottom of the same image, if we take the first image and say that is a guest moving into a room, he turns on the TV and he selects Discovery Channel, he will then, the decoder will then go back into the network and go and find Discovery Channel. And in this case, it will look on the first switch and not find it there, and then hop up to the first switch in this case. And obviously everything is present there, and it'll find the channel, and you will see the purple line then feeds that unique channel to that end user. If a second guest logs in and uses and selects the same channel, this decoder is going to query and find the information, which you will then see. It looks for the first switch, and obviously because the first guest is already watching that stream is present on that switch, and it actually just shares it. And you will see that there's still only one feed coming down from the main switch, except, and the same will happen when the third guest logs in into that same channel once again. If another guest then comes in and selects SuperSport, hypothetically speaking, the same process will take place. He will request SuperSport, which is obviously not present on that switch because all three of the other guys are watching Discovery Channel, and will then request it from the main switch, and you will see that a second stream appears. So in this case, where guys are watching the same image, they will be sharing the stream. On the unicast side, you will see that we have the same scenario where three guys are watching the same stream in this example, but and the fourth guy is watching his own, you will still see that each, right from the head end, each viewer, each endpoint has its own unique stream. Oops. So that is the distinct difference between unicast and multicast. You also see where I've indicated your bandwidth usage, although there's a massive bandwidth usage from the server to the first switch. From there, it's very well controlled and managed, and you will see that your overall, on the unicable side, unicast side, we're using 120 megabits per second to feed the 4 viewers, where on the other side, we are only using 30 megabits per second. So the unicast setup is more bandwidth hungry than multicast, but to achieve this management that is happening here, we need layer 3 and layer 4 managed switches, and we need quite a intense network setup. So there's a difference once again, just to conclude what we just viewed in the images on the previous screen. So unicast one-to-one communication, where multicast is one-to-many. As I said, unicast is bandwidth hungry because it has one stream for each set-top box, where multicast has a managed bandwidth and shared streaming. The unicast, though, is easy to deploy. It's almost a plug-and-play solution. If it's a single service network, like I said earlier, you don't need managed switches, you don't need really network setup, where on a multicast, you need an advanced network setup. Unicast, once again, can be deployed on unmanaged switches, where, as I mentioned earlier, multicast, we require layer 2 and 3 managed network switches, which are quite expensive, and once again, need quite advanced network setup, which also has a cost involved. So, in other words, unicast is a very cost-effective system to deploy, where multicast is costly and more very complex. And obviously, unicast is, because of the bandwidth limitations, although we can do various tricks to overcome it, is suitable for small to medium deployments. Also, the cost allows it for small to medium deployments, where the multicast systems are more suitable for medium to large deployments. Once again, you have managed bandwidth, but your cost of implementation is a lot higher. Okay, so when building any LAN network, each device has to be assigned an IP address, an Internet Protocol address. And that's a physical address where this device resides in the network. We spoke earlier briefly about MAC addresses, and I'm not going to go into too much depth today because we're not doing a network course here. But just a quick reference, your MAC address is your name or your ID number, or it's something that stays with you no matter where you go in life, it stays with you. Well, your IP address is more like your residential address. So Mark, we spoke to earlier with the poll, Mark Robertson will stay Mark Robertson with a set ID number from the day he's born till the day he dies. But in his lifetime, he could move to various residences. He grew up, he lived with his parents. Then he went and lived on his own. Then he got married and he lived in a different place. So those are his IP addresses. So it's important that I still know, if I want to communicate with Mark, I need to know his Mark, which is his MAC address, but I need to also know where he is so I can communicate with him. If I send a letter to Mark Robertson and I throw it in a post box, it will never get to him. But if I put on his physical address on there, or his postal address, it will get to him. So that's why it's important, because this data information gets pushed to different devices, that each device has an address and a unique IP address. Now, the DStv SATIP system can be set up using one of 3 IP address configurations. The first one being DHCP, Dynamic Host Control Protocol. In an IP network where a DHCP server is present. So in other words, in the network where you have an external DHCP server, because the SATIP server does not have a built-in DHCP server, the locally hosted DHCP server will provide dynamic addresses to all devices in the DStv SATIP network. In other words, every device, every time you plug a decoder in, Every server you plug in, even if you plug your computer in to try and monitor the network or configure the network, the DHCP server will assign an IP address automatically to that device. So that's the first option and probably the best option, but you do need an external DHCP server. These are actually not expensive. Your very basic domestic sort of routers that you even have in your house, those have all got DHCP servers on board. So you do not need a very expensive device to act as a DHCP server. The other option is a function called auto IP, and in a network, IP network, where a local hosted DHCP server is not present, the DStv SATIP server will automatically generate an IP range and allocate IP addresses to the network devices. So this works very similar to your DHCP, gives a similar result where devices receive IP addresses automatically, but it uses a different protocol called auto IP. So in other words, if you have a small network, you do not have a DHCP server, the actual DStv SATIP server will allocate the IP addresses. This process is quite a bit slower because the server will first go and hunt the network and try and find the DHCP server before it actually enables auto IP. So although once it's running, it works fine, the DHCP is still the preferred option. And then the last option which is possible is static IP. So when using static IP addresses, each device is allocated a static or fixed IP address, and a static IP address is configured manually on each device. In other words, you have to log into each decoder, each server, any other device that you have on the network, and physically, manually type in the IP address and store it into the device. Now, this could be quite tedious on a large network, firstly. And secondly, you do run a risk, and this is also, we've had this practical experience with the installation where the installer opted to run static IP, and when things like load shedding or even sometimes firmware upgrades on decoders, like we all know, they tend to reset to factory defaults. Now, in this case, the factory default is a automatic IP search, which means in that case, your static IPs get lost, and it means you have to go through that entire system again and reconfigure all the devices and add them in again. So it could be quite tedious. So for that reason, we do not necessarily recommend static IP, but it is possible to use should you prefer. Okay, so we spoke earlier and we said we had a twisted pair cable instead of coaxial cable. So the twisted pair cabling, two conductors in a single circuit are twisted together for the purpose of improving electromagnetic compatibility. The advantage of twisted pair, it reduces electromagnetic radiation from the pair, it reduces crosstalk between neighboring pairs, it improves rejection of external electromagnetic interference, and it was invented by Alexander Graham Bell in 1881. So on the left-hand side, you'll see that is what a twisted pair cable looks like. So there are the reasons, as mentioned, why these cables are twisted together. They're not just to look pretty or try and sort them and they don't get mixed up. There is some real life reasons why they are twisted like that. And that's why important when you set these things up, that it's done in a proper way. There are two main types of twisted pair cables, being the UTP being the unshielded twisted pair, and the STP being the shielded twisted pair cables. And there are various category cables. We talk about Cat 5, Cat 6, all the different types of cables. And this is just a quick summary why we say Cat 5e or Cat 6 at least. If you look at the standard Cat 5 cable, without going into too much detail here, you will see it has only been designed for 100 megabits per second Ethernet. We already said that one server could require up to 690 megabits, which is more towards a gigabit, which is 1,000 megabits per second. So for that reason, the Cat5 cable is not suitable for these type of installations. And therefore, we recommend Cat5e or Cat6 cable, which allows you the highest throughput and the high speed that you require. Then when you adding the RJ45 connectors to your Cat5 E or Cat6 cable, once again, there are two specific wiring codes, the T568A and the T568B. B is more commonly used, but you could use either or. It's just important that you use both on the same. If you use 8B on the one side, you must make sure that you use 8B on the other side. And as you can see, there's a very specific color coding in this. And as we said earlier, the twisted pair cables are twisted for a reason, and that is also why the order of these cables are very important when making off these cables to ensure the efficient functionality of your network. Getting to the last building block of this system being the viewing environment. We said the SATIP system was designed to make use of a standard multi-choice HD single view decoder to ensure encode and decrypt IP streaming at each viewing point. Currently, it is only the 5U and 5S. I think there's only 5S's available in the market, multi-choice decoders that are compatible with DStv SATIP. They're the only decoders that currently have the firmware in it. Although the 5 has obviously been replaced by the 6 already. There are 5S decoders available from ourselves for SATIP deployments. So if you are doing a SATIP deployment, please ensure that whichever branch you're dealing with, that you specifically make sure that they supply you the 5 series decoders and not the current 6 series decoders, because the current 6 series decoders are not SATIP capable. As far as I understand, is the next generation, which will probably be the 7 series decoders, will once again be SATIP compatible. But for now, if you do SATIP deployments, please make sure that you use the 5 series decoders and not anything else, because they're the only decoders currently compatible with SATIP. So here's the back end of the 5 series decoder. On the left-hand side, we have the LNB input, which we will not be using in SATIP, but we have an Ethernet input, which is obviously where our LAN cable will now connect, and this will become the input of the decoder instead of the coaxial feeds from a satellite dish as we've grown accustomed to. Once again, our USB port. Then we have an HDMI output and an AV output. So depending on the TV set it's being connected to, typically you would want to use the HDMI output to achieve the HD quality images. But should for whatever reason you still have an old CRT type TV, you could still use it by adding the AV output. And obviously we have the normal power supply input. I think these decoders you should all be familiar with. So the main difference here is that we're not using the LNB input anymore, but we will be using the Ethernet input on a SATIP solution. So when you go into your decoder setup wizard for SATIP, you go into your normal setup and you will find under your LNB type, it will not just have legacy and unicable, it also has a SATIP option. So you will change your LNB type to SATIP and click scan. A prompt will open a request to reboot the decoder, which will then, after the decoder has rebooted, use the wizard again and select LNB type as SATIP. The decoder will begin server discovery and perform a signal check. And then you can click scan and the server will, and the decoder will boot virtually as normal. Only difference is you are now getting a SATIP feed, but from a normal setup, the decoder will then virtually function as normal. So it's just important to make sure that your LNB type is set to SATIP, and obviously the decoder will then require the rescan to set itself up for SATIP, and then it should function normally. Very quick network design. There's a few important facts which we've covered, I think, in this presentation. The first thing is obviously use a commercial grade satellite dish. The wideband is the preferred input for DStv SATIP. Layer 2 unmanaged network switches, data switches are sufficient if it's a single service network. If you are running multiple services on the same network, so you might have internet access or telephones or cameras running on the same LAN, it is possible, but then you need a managed network very similar to what was the case in a unicast network. A multicast network, where you need to be able to set up certain protocols within the network. As we said, your server requires at least 690 megabits per second when fully populated. So it's important to have a gigabit port for the trunk port on your network switch. The switches we sell, all the ports are gigabit ports, but there are some cases where you get switches which has gig trunk ports, and then the 10-100 or the 100 meg ports, which are still sufficient for the decoder, because the decoder only requires 30 megabits per second. So as long as your trunk port is at least a gig. As we said earlier, always use Cat5e or Cat6 screened cable preferably, because there are also external interference which could cause issues in your network. And standard data network protocol, a single Cat cable run may not exceed 100 meters. In other words, from your server to the switch, and from your switch to another switch if required, or from your switch to the endpoint, the cable run may not exceed 100 meters. And this is to do with timing and how data networks work. And when we do another training course more on data networks, we'll go into detail of all of that. But for now, just remember that your single run cannot exceed 100 meters. Obviously, ensure that all your RJ45 connectors are crimped correctly, as we mentioned earlier, and use either the A or the B standard. Do not mix them up. Each decoder on the network requires 30 megabits per second, as we've mentioned, and do not exceed the maximum bandwidth of the network switch. As we said earlier, depending on the port, if it's a gigabit port, and I'll show you some practical examples now to explain it more clearly, you cannot exceed the bandwidth of what that port can handle. And we said a maximum of 23 decoders per server. Okay, so there is a basic setup. Can we do that? We said we can use a smart LMB to feed a server. You've got 30 user bands on the LMB and 24 in the server, so that is correct. That is a practical and usable example for a small system. Can we do this? We have two servers which require 24 user bands each, which is a total of 48 user bands, and our LMB can only supply 30. So no, we cannot feed more than one server from a smart LMB, very important. Here's our wideband LMB, one vertical feed, one horizontal feed into a server, and that we said we can do because that allows us to have all the services and signals from the dish that we require. Can we do that? We take each output and split it and feed two servers. As we said, there's no switching, so that is practically possible. Obviously, if it's long runs, etc., you might need an amplifier as normal RF goes. But the bottom line is you can build a distribution system behind a wideband LMB to feed more than one server. When it comes to fiber, this is an interesting one. If we have a large network, these servers could be fed by fiber. And in this case, I've got two examples. On the left-hand side, I have the multi-choice Zenwell GTU, which has 30 user bands shared. So that's, the outputs are similar to a smart LMB. And on the left-hand side, I have the Global Invacom DSR GTU, which has two outputs, but each output only has 16 user bands. So what is practical? Yes, on the Zenwell, we can use the Zenwell GTU because it shares the 30 user bands. Once again, only one server per GTU, but we are able to feed a server from the Zenwell GTU. Unfortunately, on the GI has a total of 32 user bands, but it's only 16 per port. We can only connect to one port at a time when using unicable, and therefore we will only have 16 user bands of the required 24. So no, we cannot use that GTU. So once again, if you want to use fiber, you can use the Zenwell GTU to feed a SATIP server, but you cannot use the Global Invacom DSR GTU. And just out of interest, if you use something like the Johansson or other DSCR multi-switches out there, you will have exactly the same problem, that each output only has 16 user bands. And once again, those cannot be used to feed SATIP servers either. Basic network setup. So you have a wideband LNB feeding your server, Ethernet port into the switch, and your switch, each port feeding a direct feed to the decoder in each room. Up to 23 decoders from a single server. For our guys from the other African countries which are logged in today, Africa has a slightly different requirement, and part of their requirement is that the system needs to be connected to the internet, because they have a monitoring protocol which they need to access. So for that reason, each server needs to be directly connected to the internet at some point, so they can access it for monitoring purposes remotely. So just keep that in mind for the guys from the other African countries which are present with us today, that you need an internet connection into your system. So here's just a quick, typically what could be quite a large system. So here I'm running about 69 endpoints, and I also have a redundant server in here. So I've got 3 servers plus my redundant server, and each of these servers can push up to 690 megabits. And as long as my switch, all the ports are gigabit ports, that would be fine. I would not overload anything. And then once again, one port feeds a separate switch, which once again cannot exceed 690 megabits because there's no more than 23 connected there. So as long as all my ports are gigabit ports, which is 1,000 megabits, I will only be running a maximum of 690 megabits on each port, which means I will not overload anything. Obviously, going out to the decoders, those could be 10-100 ports or gigabit ports, because we will only need 30 megabits per second on those feeds. So that is a fully workable solution. And as I said, we have a spare server. Should one of these servers die, that server will take over the function automatically, because whichever of the endpoints are connected to the server that's died will just switch over to that server automatically. Okay, so that is a workable solution. So here's another interesting one. If I bring my 4 servers again into a switch, but I run a trunk from one switch to the other and then only feed out to my subnetwork, what's going to happen here now is that I will have 3 servers running at 690 megabits per second, which gives me 2,070 megabits per second, running on a 1 gig trunk, which is 1,000 megabits. So in other words, I will be overloading that port, which means I'm going to have a serious data loss and collisions, etc., in my network, which means I will probably have picture breakup on most or all of these decoders. So be very careful when trying to trunk something. There are switches with 10 gigabit ports available, which will overcome this problem, but they are very expensive. So the easier way is to just segregate the network to ensure that you do not achieve this overload scenario, which we've just seen here. So just keep that in mind. So obviously this is not a workable solution. Okay, very quick system config. How do I find my SATIP server in the network? So I connect my PC into the switch, into the network switch, and I go to this PC function on my Windows computer, and I click onto the network port. If you are using a static IP, you will have to assign your PC an IP address in the range. If you're using DHCP or auto IP, it will receive an automatic IP address, so it's not a problem. It should log in automatically. So you go into your Windows, you go to this PC, and you will see on the left-hand side, you will see an option that says network, which you click on, and this will show whatever's in your network. And you can see this was Mark's computer it was done on, so it says Space TV Randburg Mark Robertson. there was a TP-Link device in the thing. There's a wireless routers, and Windows has got a function called Universal Plug and Play, UPnP, and that function will discover everything that's on the network. That's how Windows discovers printers and all these funny things. Often you get a big list of devices here when you log into a network. And using the UPnP, Windows will automatically discover the SATIP service. You see it's MCA, multi-choice SATIP. So there's your server. It'll pop up automatically within your network parameters using Universal Plug and Play from Windows. If you right click on it, it'll give you view device web page, create shortcut or properties. You will right click on the properties bar, and this will open the properties. And it'll give you some information, who the manufacturer is, what the model is, etc. And it'll give you what it says device web page, which is another IP address. If you click on the device web page, it will open up your browser, whatever you might be using, Google Chrome or Internet Explorer or whatever. And it will open up the web GUI, the graphic user interface of the SATIP server, which would look something along those lines. So that's what you will see. Here you see there's your 24 tuners for your, which will be other user bands, etc. It'll give you statistics of what is locked onto the system, etc. So you can see how many decoders are actually active on the system. In this case, we had one. And also at the top there of the blue bar, you will notice that it tells you what the software version is of the device, how many clients. There'll always be a minimum of 2 if you've got one device, because the second stream is the data stream. So if you add a second device, it'll be 3, because the data stream obviously gets duplicated. You can see what the CPU load is of the actual device. You can see the memory current being used. You can see how long the device has been up, and the network traffic at this point in time, which is quite low. So if you want to access any of the other functions here, you would have to log into the device. So if I for instance, select network settings, it will prompt me to log in, where I will need a username and a password. Now that's very simple. If you look on your SATIP server that you would be busy configuring, all the information is there. There's the model number, there's the MAC address we spoke about earlier, and there is your default username being SAT_IP, and your default password is AJ_JJVR_0706. And the AJ and the JJVR are actually the initials of the developers, funny enough. But anyway, so your username and password is actually on the sticker on the device, where you can find it, and you can enter it here to log in. And once you log in, push the login button, it will now access you to network settings. So here you'll see there is your IP mode. It is set to dynamic. In other words, it is now waiting for either a DHCP address, or if there's no DHCP, it will automatically go to using the auto IP. You can change that. If you click here, you can change that to static, which then means you will have to add all the information in manually, as discussed before. The next tab is just the admin tab. So there's your device serial number, if it's on a unicable, and then here you can add a friendly name. In other words, if you have multiple servers and the one sits on one feeds floor 1 and the one feeds floor 2, for instance, you can actually give them names here, so or wing 1 or block A or whatever that makes sense for your installation. So when you discover them on the network, you know exactly which is which. And you can also change that default password, that AJ_JJVR password. You can actually change here to a unique password should you want to, and then just apply. Should your SATIP server require a firmware upgrade, now this one is currently on 1.03. The latest version is 1.08. So this specific server would require a firmware upgrade. You go to this tab, make sure that you have the firmware available. We can assist with it somewhere on your computer. So you just browse, point your computer to the actual file, and you push upgrade. And it will automatically upgrade the server while it's running. And then it will just be a quick reboot process, and it will be running back on the new firmware version. And then you have a logout. And that is basically the only configuration that needs to be done. Like I said, once again, this is your monitoring screen, which you can see how many decoders are live, how many are active. If you're using SATIP, it'll actually tell you which user bands are allocated, etc. So that's a simple setup of the actual device. And I think that's it for my side. Let's look at any questions now. We will open the Q&A session. Any guys who have any questions regarding this presentation and the solution, please go to the bottom of your screen, click on the Q&A tab, and you can just type us your questions. No questions? Okay, there we got one. Okay, Gregory, thank you for the presentation, very helpful and informative. Thank you, Gregory. I'm glad you found it informative. Reinhard Leroux, please send me a link for the session. Reinhard, on the screen is the email address info@spacetvacademy.co.za. Please just send us a mail to that address, info@spacetvacademy.co.za, and we can assist you with that. Not a problem. So that was done, Gregory done. Charles van der Westhuizen, how often must the software be updated? Charles, that depends on when there are new builds coming from MultiChoice. At this point in time, there's only been one upgrade virtually from the 0.3 to the 0.0, which I think at this point is running quite stable. So there'll only be, there's no specific set time. I suppose if there's a bug fix or they want to add additional features, etc., to the server, there will be there'll be a firmware update. We will obviously try and advise guys if it does happen. Anthony, highlight a bit on the cable run. I presume you're referring to the 100-meter limitation on the cable run. That is standard data network protocol. It is to do with delays. It's not to do with losses. The amount of time it takes the device to send data down the cable and receive an answer back. Remember, these networks are fully interactive. There's constant up and down communication. We will be doing a data network training course at some point, which we will actually have more details on it. You'll also see when we're done here today, our next webinar is already going in that direction. Alan asked, where does the DHCP device connect? It is just another device which will just connect onto another port on that network switch. So your core switch where your server is connected, the DHCP device will just connect to a port on that device. As I said, because all these devices have got their own unique addresses, as I said before, they all just connect on each on their own port, and the communication goes via the address. Alex is asking for the price range. Alex, once again, just drop us an email, info@spacetvacademy.co.za, and we can share pricing with you. Can I use the same? Robert is asking, can I use the same idea to another decoder? Robert, currently it is only the 5 series MultiChoice decoders, the 5 S's and the 5 U's that have the correct software. They're the only ones that you will find that IP option under LMB options. Samir asked, where does the subscription sit? Samir, because it is a commercial subscription, the owner of the hotel or the office or hospital or whatever you might be installing this thing will have a commercial subscription agreement with MultiChoice. In any commercial subscription, you pay per viewing point. So in this case, it'll be whether you have like an old traditional RF head end, which sends RF to 100 rooms, or you have 100 decoders, one in each room. The subscription stays the same. Obviously, we are using a multi-choice decoder in each room, so the control from the subscription perspective happens within the decoder, because obviously the decoder has a virtual smart card, which is where the subscription is controlled from. Henry is asking, in a SATIP installation, why do some decoders display no signal until reboot the decoder? Henry, difficult to say, but in more than likely, this could be an IP address issue. So when you reboot the decoder, it receives a fresh IP address or a non-conflicting IP address, especially if you're using DHCP or auto IP, which then allows it to be communicated to. Like I said, if I send an email to Henry, it goes nowhere. If I send it to Henry then you will find it. So if it hasn't got the right address, it will have no signal, because the server doesn't know where to send the signal to. Oops, what did I do there? Sorry, did I just delete the wrong one here? Calvin is asking, thank you, OVSD will not run in the system. No, Calvin, this system is, it's a multi-choice, it's a DStv product, and it's designed only for use on a multi-choice platform with DStv services. Marvelous is asking, how about if you are found in a situation where you don't have a meter that can measure wideband LMB? What can you do? As I said earlier in my presentation, as long as you've got a satellite meter, it is possible to measure, to align a dish with wideband by changing the oscillator. Marvelous, once again, if you go to the spacetv.co.za website, under the video section, you will see there are videos on instruments, and amongst those videos there are, for most of the models that we sell, which could be applicable to others as well, it'll explain to you how to change the oscillator and how to align the dish with that meter. Fani asks, can you have internet on the same network? Fani, yes, it is possible to run a multi-service network, but as I said earlier, when you run multi-service networks, you have to have a managed network. So you need to have managed switches, because you need to be able to set up VLANs, etc., to be able to control quality of service, to make sure that your decoders, for instance, get priority and you don't have a breakup in a picture. I mean, if you're surfing the internet and it takes a second or two later for your page to open up, it's not a train smash. But if you are watching live TV or even have a phone call going on the same system, those need priority of service. So for that reason, you can do it, but it becomes a more complicated network setup, because it's very similar to the multicast setup. You need to have a managed network. Alex is asking, how will ExtraView work? Alex, as this is only for commercial application, there will be no ExtraView. This is a commercial subscription where you're paying per viewing point. So there's no ExtraView per se, because it's not for domestic. ExtraView is only used for domestic applications. Then Zuko is asking, what are the key selling points compared to the normal BNB current DStv setup? Okay, Zuko, so I think one of the very key selling points is the fact that you can now, I think there's two words which are the buzzwords here, and the one is cost effective and the other one is HD. So in other words, you are now able to have in your BNB, you can have HD quality pictures and not your standard RF analog pictures, which is typically what was the case before on an analog system, on an RF system, in each room at a very affordable rate. Because as I said earlier, your digital systems, your HD type head-end systems, third-party systems can cost easily R500,000 or more, where this is a fraction of the cost. And also the other nice feature is that your guest or your viewer has a decoder and a on-screen display and a standard remote that he's probably used to, because it almost gives you the at-home feeling, because it's all familiar to you, and you still have your standard EPG and all the things that you would have at home. Another advantage also is on the SATIP is typically in the traditional RF systems where you would have a head end with selection of decoders, etc. You select a specific number of channels. So you decide to feed 10 channels, 20 channels, depending on what the requirements are. But very often your package, which you are subscribed to, probably includes 40 channels. So by using the SATIP solution, it's a totally transparent system. So whatever channel that your subscription package covers will be available in the room. So that's another advantage. So there are actually many advantages of the system. It's also scalable. You know, I can carry on, but the key selling points, I think, is the cost-effective HD solution and that at-home sort of feeling. What's the next one here? We have from Walter. Do I need a special accreditation to do SATIP installations? Look, obviously, from the accreditation side of it, that is something that you will have to discuss as MultiChoice. From our side, we are always happy to assist you and help you with this installation. As I said, if you do a single service installation, it is actually almost a plug and play solution. So it's quite simple to set up. If you have a specific project that you want us to help you with, just send us an email once again to info@spacetvacademy.co.za, the website, the email address on screen. And then we have Kahuya, I hope I pronounced your name correctly. He says, I'm from Uganda. Some of the HD decoders like 7s do not have LAN ports. Can they be used in SATIP? As I said earlier, currently only the 5 series decoders are capable of or compatible with SATIP. They are available even in country. If you speak to the guys there, they should be able to assist you if you do SATIP with the 5 series decoders for this application. Next generation decoders, I believe, will have SATIP compatibility once again. Dina, can I activate this DStv IP boxes using installer portal? That's a good question. No, I don't think so, because you will have, no, you won't, because whoever is your customer, the owner of the hotel, etc., will have to first sign up a commercial agreement with MultiChoice on the commercial side. I'm not 100% sure if the installer portal covers this. You can send me an email at info@SpaceTV Academy, and I can just confirm with you, or confirm for you, just to make sure. But there will have to be, before anything gets done, there will have to be a commercial agreement between the owner of the site and MultiChoice Commercial. I've got a Howie phone here. Will the 5S decoders still be available? As I said, they're not freely available in the market, but they are available in South Africa through Space TV and also in country through different MultiChoice agents or offices in different African countries. So they do have stock available, but they only make them available for SATIP installations. You cannot buy them for normal installations. So if you want to do a SATIP installation, just specifically ask for it, and the 5Ss can be made available. And I've got Fred here. Thank you for your presentation. My question is, do I need more than one wideband LMB if I am to use more than one server? If you have a wideband LMB, you are able to build a distribution system behind it. In other words, you can, like I had those quick graphics there, you can split them. There are wideband amplifiers available. There are wideband taps and splitters available. Most of the RF splitters that we sell today are wideband compatible already. You will see that the range runs from 5 megahertz up to 2.4 gigahertz. So just make sure if you build a distribution system that all the components you use cover the wideband frequency, but then you can build a network as big as you like. Like I said, even if it's a large network, you can even use fiber to feed as many servers as you may require. Themba, is this one DStv IP recommended than legacy switches where you run switches and amplifiers? Okay, so for a commercial environment, in some cases, even in offices and stuff, they might already have that data network infrastructure in place, so then this makes sense. There's also a quick and easy installation if you want to do it from a fresh installation. Also, once again, for the guys from Africa, because of the unbundling that they have there, you are not allowed to run an RF or a multi-switch network and feed decoders in a commercial installation, barring SATIP. So if you are from one of the African countries, just out of interest, this goes for everybody, this is the only way that you can do decoders in a commercial environment at the viewing point, is using SATIP. It's not allowed in Africa because of the unbundling rules that's been in place for the last couple of years. Dina, can multi-choice installer portal be used to activate the DStv? Okay, as I said, I'm not 100% sure. Once again, drop me a mail and I can try and confirm that for you. SATIP doesn't lose signal when it's raining. Joel, it will still lose signal because your loss is from your dish. It's on your downlink from the satellite to the dish. If there's a large enough storm, the rain creates noise, etc., and it does deteriorate your signal to your dish. But as I said earlier, hence the reason, use a commercial quality and a larger satellite dish that will minimize your rain fade. But you will never get away from rain fade completely. If it rains hard enough, they will even lose uplinks. Can Space Ultra Plus measure wideband, Clive? Clive, unfortunately, the Ultra Plus does not have a wideband tuner. It is something we are looking at the moment, though, but at the moment it cannot measure wideband, but you can still use the option. I think the video is on our website, on spacetv.co.za. Under the video section, there is a video on how you can use the standard Ultra Plus to align a dish with wideband. Henry, thank you for the reply, but what causes the server to keep on losing IP addresses? Because you may find that at least after every 2 days, you may need to reboot some decoders. Okay, Henry, look, there are various options that could be your problem. I think I would suggest maybe just drop us a mail at info@SpaceTV Academy, and then we can take this conversation further and see if we can help you. There are various reasons. One of the first things I would just ask you to look at maybe is what firmware version is on your servers. Because if you are still on the 1.03 version, that could be your issue. The 1.08 runs a lot more stable. But please, Henry, just drop me an email, info@spacetv.co.za, and we can discuss this issue and see if we can try and resolve it for you. Because it could be network related. There are various issues that could cause it, which is a bit more complicated than to discuss here right now. So I'll wait for your email, Henry, and then we can try and resolve your issue for you. Lucky, why is it that the trunking switch not recommended? It is because the unicast feature of SATIP servers. Lucky, as I said, if you start trunking multiple servers, which each require 690 megabits per second, you only have a gig on a standard network switch port. So even if you only have 2 servers, they can require 1,300 and whatever odd megabits per second, which will overload the port. If you start segregating the network, it actually keeps it a lot simpler, and your chances of overloading anything is very simple. What we've done often is we would, there's a scenario of a customer of ours did a hospital where they actually had about 20 odd beds in every ward. So they did a fiber distribution, the normal DStv fiber distribution to each ward, and put a Zenwal GTU with a server feeding a 24-port switch in each ward. So the network is completely segregated, none of the servers see each other, so there's no chance in actually overloading the network whatsoever. Lucky, in 2 weeks' time, we will be doing a webinar on network switches, where I think a lot of this will be explained more clearly to you as well. Anthony Osman, Tony, good to have you. Thanks again for the training, all the way from Malawi. Are the rumors of Netflix coming to DStv, and if so, will the service be embedded in SATIP? Tony, as far as I know, it's not a rumor that Netflix will be coming onto the DStv boxes. I think it'll only probably be on the new generation of Explorers. I think, I stand to be corrected, which I assume or presume at this point in time that it would not be available on SATIP, as SATIP is obviously for commercial use. I think that the Netflix would be more aimed at domestic use, but unfortunately I cannot give you a direct answer on that. I'll have to go and ask some questions. If I find out anything, we'll definitely let you know. I'll get Mark to just give you a shout. Nicholas, do we have wireless one currently, or any plan for the future? Okay, so look, this is not necessarily designed for wireless. I presume you're asking the reason because I've had this question before. It is not totally impossible to do, but one would have to be careful when approaching that, because your wireless network would have to be quite substantial, and you would also have to have some form of devices at your decoders, because obviously your decoders do not have wireless built into them. It is possible, not ideal, not recommended probably either for that matter. Gideon, hi. In a situation where you need to run more than 100 meters of cable, what do we do? Or is there any gadget we can use? Gideon, the 100 meters are only between devices. So as long as there's a network switch within 100 meters, you should be fine. So the idea is if you need to run more than 100 meters, you need to run through a different device. Your other option is to use things like, depending on your switches, you have things like fiber SFPs, you have media converters, which allow you to run fiber optic cable instead of cat cable, which basically then you can run the thing for kilometers. Once again, in 2 weeks' time, on the 23rd, I think it is, Mark will be presenting a webinar on data network switches, and a lot of these type of questions will definitely be covered in those sessions. So Gideon, I suggest watch out for our marketing. Should be on the 23rd of July, if I'm not mistaken. It's today. In 2 weeks' time, there will be a presentation on switches which will explain those things to you. But in short, fiber optics will overcome that problem. Lucky, some customers are still not comfortable with running cable all over the building. Same way as RF installations. Is there advancements in future to come up with antennas that can link the decoders and or router switches just like computer networks? Lucky, thanks again for all the way from Uganda. Like I said, Wi-Fi and wireless links and all these type of things are possible. It becomes quite tricky, but it can be done. And I suppose as these products and things develop, it might become more common, but it's not impossible. Robert, how about to pay packages for all 23 decoders? Robert, once again, any commercial subscription, whether you have a centralized head-end feeding RF to each TV, in any commercial subscription, may it be a hotel, hospital, office, pub, etc., your payment is per viewing point, regardless of what the distribution is. There's a specific cost per month, depending on the package that you choose. There's obviously various commercial packages available that you can talk to the multi-choice guys in your respective countries, what the cost of these are, but it ends up you're paying per viewing point, regardless of whether the decoders are centralized or at each viewing point. Galaxy, Tanzanians have not received this, but for training, is there any plan to bring a multi-choice training to Tanzania? Sure, I don't know. That I'll have to talk to Aubrey and the guys around from Africa. I know there were plans this year to do the biannual training sessions in country from Multi-Choice Africa. I know I've been involved in some of them myself in some countries. I haven't had the privilege of going to Tanzania though. But I think with the whole COVID situation, obviously traveling, etc., is challenging at the moment. That is obviously why we're also doing the online training at the moment. But I don't think Tanzania is definitely not out of the question. Maybe if you invite me, I can come and visit you once COVID is over. Matt, can one use any network switch, or there are special switches for this? Matty, basically, there's a few things that's important. Obviously, if it's a single service network, you would use a unmanaged switch. A managed switch can still be used if you wanted to, but it's not necessary. The trunk ports have to be a minimum of a gig port. The other ports doesn't make such a big difference. It could be a 10100 port or a gig port. The bottom line is a good quality switch, I think, is the trick, because we are streaming video, so it's a massive amount of data. It's not like internet traffic or whatever, or sharing files, etc., on a LAN, which is sort of intermittent traffic. So a good quality switch would definitely be advised. Once again, Matty, in 2 weeks' time, Mark will be taking you guys through understanding of switches, etc. And I think he would probably answer these questions for you. So yeah, in 2 weeks' time, well, look out. It'll probably be out next week or so. Look out for the marketing and then try and join that webinar. What happens if I connect more than one decoders to the server? The server can only accommodate 23 decoders. So if you connect more decoders than 23, the other decoders will just be waiting for signal, because they will not receive any signal, because the decoder can only accommodate 23 decoders. So it won't do anything to the system. The larger number than 23 will just not receive any signal until you add an additional server. Anthony, we have run up to 120 meters of CAT, the ground cable from server. Anthony, it is always possible, depending on the cable, but as network standards go, it is not recommended, because it could cause issues. The 120 meters is probably, if you go and work it out strictly, is probably the limit, but it is internationally accepted standard that 100 meters is the limitation to guarantee throughput. Because also remember, if you start running longer cables, it might work, but effectively your throughput on that cable becomes lower. So you only need 30 megs, so you're probably getting away with it. If you try to get a gig through it, you probably find that you would have some serious losses there somewhere. Sure, that was a good question and answer session, 50-odd questions. Anybody else with any questions? I hope I've answered most of your questions. Once again, anybody else that has any questions, has projects, etc., please just drop us a mail to info@SpaceTV Academy, and myself and my team will definitely contact you and try and assist you. Guys who've done some systems, have had problems as well, etc., please just contact us, info@spacetvacademy.co.za, and we'll be happy to assist. Anybody else? I think, there we go. Can we have this training with certificate given? Dina, unfortunately, I can't give you a certificate because I don't know what you've learned. We are looking at options for training with the examination at the end. Obviously, this whole webinar platform is a new initiative which we only started a couple of months ago, and we are growing and developing it all the time. We are working on that option where we can issue you a basic certificate following the training. So just try and, just keep an eye out for webinars coming up, and we will be definitely doing that in the future. Anybody else? Okay, I think we've had a good session today. I think it's been great. Thank you very much. Who's that? Will the 5S decoder still be available? The 5S decoder is still available currently, and as I said, if you just ask for it at the Space branch, or if you are in one of the African countries, just talk to the local multi-choice agents or officers there. They will be available, and they will stay available until the, I think it'll be the 7 series, because we're on the 6 now, becomes available, which I believe will have SATIP compatibility once again. But to say the 5Ss are available, they're just not sold over the counter because they're not used for normal installations any longer. Anybody else? Once again, anybody afterwards, any questions, anything, just drop us an email. Kelvin, hi, this intro, how can a certificate be expected? This market will be flooded with the unknown. Kelvin, 100%, this is purely intro, and there's, due to the time restriction, there's a lot of stuff that has been omitted from the session. Like I said, we are looking at other options, which might be extended training sessions over multiple sessions, etc. This has not been finalized due to the fact that we have to be careful what we do in the thing. Lucky, we appreciate your time and commitment to upskill us. Team Valley, Team Space, big up. Lucky, thank you very much, and thank you for you guys as well. Yourself and all the other colleagues, I think, from various African countries that join us on a regular basis. We also appreciate it. And yeah, hopefully, like I said, we had some plans, Martin and myself, to visit some of your countries this year. And unfortunately, I think with the COVID thing, it's gone a bit south. But yeah, hopefully, maybe next year we can do some in-country training again. It's always interesting to visit all your countries and learn and see from you guys. So yeah, we look forward to it. But yeah, please keep an eye out. We'll keep you updated on the upcoming sessions. As I said, the following one will be on the 23rd of July. There it is there. Introduction to data network switches. Some of the questions asked here this afternoon or this morning will be answered there. Mark will be handling that session. So watch out and keep your eyes out for the marketing. Once again, guys, thank you very much. We really appreciate your time as well to attend these sessions. Also, if there's anything interesting or anything that you would like us to do training on, once again, our email address there, info@spacetvacademy.co.za. Drop us a mail with your ideas. Yeah, maybe we can do a session on that as well. You know, we try and cover things that we believe is relevant, but maybe there are other things that we are missing on. So if you guys have got anything that you would like us to do training on, may it be a product, may it be a solution, please let us know on info@spacetvacademy.co.za. Okay, so like I said, on the 23rd of July, you will be in the capable hands of Mark again, doing the data network switch session. Next week, being the 16th, there will be no live webinar, but we will be streaming the webinar. It was a couple of weeks ago that Clinton did on the IP CCTV. We will be streaming that live on Facebook. Once again, just watch out for the marketing. And you guys must watch. You must look out for that. We're doing every once in a while. We restream some of these sessions on Facebook. we try and schedule a few times during the day and also one in the evening. So for the guys who are out on the road busy, that are not able to attend the live webinars, you can get home, relax, have dinner with your family, and then sit down and still watch the webinar. What is Lucky saying here? If possible, Space should have regional offices, east, west, north, where we can order most of these equipment. Sometimes it becomes expensive ordering from SA. The repair warranty for these equipment becomes hard. Lucky, yes, something which are being looked at, not always so easy to do, but definitely something that definitely can be considered and will be considered and is being considered. And that's it. I think thank you guys once again. We look forward to hosting you again soon at one of our upcoming webinars. Once again, any information you require, any ideas, suggestions, questions, info@spacetvacademy.co.za.